All right, in this video, we're going to talk about section 2.7 dealing with inverse functions. All right, so in this video for this section, we'll talk about how to verify inverse functions, also find the inverse of a function and use the horizontal line test to determine if a function has an inverse function. All right. Now the part for inverse functions is going to build from what I talked about in the last video, which is the composition of two functions, f and g, and also the composition of g with f of x. All right, so here's the definition of the inverse function. I'm going to let f and g be two functions such that f of g of x, or the composition of f with g of x, is equal to x, and the composition of g with f of x is also equal to x. Now, for the composition of f with g of x equaling to x, that's going to be for every x in the domain of g of x, and g of f of x is equal to the x, and that's going to be for every x in the domain of f. Okay, so that means that the function g is the inverse of the function, and it's going to be denoted by f inverse. G is the inverse of the function f, and it's denoted by f inverse. And this is not f to the negative 1. That's not an exponent. That's just read as f inverse. All right. So as I mentioned earlier, we're going to use the composition of f with g and the composition of g with f, as discussed in the prior video for this section, to show that f and g are inverses, like in this first example. Here we got f of x equal to 3x plus 8, and g of x is equal to x minus 8 over 3. And in this case here, I want to verify that these two functions, f and g, are inverses. All right, so first of all, this is what I'm going to do. I'm going to find, in this case, f circle g of x. That's going to be f of g of x. Okay. And by the way, to verify that two functions are inverses of each other, you want to find out if the composition of f with g of x is equal to x, and also the composition of g with f of x is equal to x. They have to be the same for it to be inverses. So like in this case here, f circle g of x, that's the same as f of g of x. Here your g of x is your inside function. And g of x is that x minus 8 over 3. So I'm going to replace the g of x with x minus 8 over 3. So I'm going to be evaluating f of x minus 8 over 3. Now here, f of x is 3x plus 8. So for each and every x in the f of x function, I'm going to substitute it with what g of x is. And of course, g of x is that x minus 8 over 3. So if you recall, this x in f of x is substituted with g of x, which is x minus 8 over 3. And in 3x plus 8, that x will be substituted with g of x, which is x minus 8 over 3. Then we're going to simplify the right-hand side. Well, notice that this 3 is like 3 over 1 times x minus 8 over 3. So those 3's divide out. And you'll be left with x minus 8 and then the plus 8. Well, minus 8 and the plus 8 are gone when you combine those two. You'll be left with just x. Okay, so now I got to do the composition. So this is what the composition of f with g of x is. It's equal to x. I also got to do the composition with g of g with f of x. That's this. it also must be equal to x. Well, the composition of g with f of x, that's just going to be g of f of x. This time my inside function is f of x, which is, of course, 3x plus 8. So I'm going to be finding what g of 3x plus 8 is. And g of x is at x minus 8 divided by 3. So here, for each x in g of x, I'm going to substitute it with what f of x is. Okay. Now, in this case here, for the x, that f of x is what is 3x plus 8. So I'm going to substitute that x with the 3x plus 8. And in x minus 8 over 3, that x will be replaced with what f of x is, 3x plus 8. Now, in this case here, I can write this without the parentheses as 3x plus 8 minus 8, all divided by 3. The plus 8 and the minus 8 add to 0, so that's gone. I'm left with 3x divided by 3. And of course, the 3's divide out. You're left with just x. So the composition of f of g with f of x is equal to x, which is also the same as the composition of f with g of x. That's also equal to x. They're both the same. So I can conclude that f and g are inverses. Now, had this been x and this been something else besides x, then they would not be inverses. They have to be the same for the composition of f with g and the composition of g with f, for you to conclude that f and g are inverses of each other. All right, here's another example. Let's say I want to show that each function is the inverse of the other. Here I got f of x equal to 4x minus 7, and g of x is equal to x plus 7 divided by 4. Okay, so again, I have to do the composition of f with g of x, and I also got to do the composition of g with f of x. I must get the same thing. They both have to equal to x for it to be inverses. So the composition of f with g of x is the same as saying f of g of x. So here g of x is your inside function, and g of x is the x plus 4 over 7. So I'm going to bring down the f and replace the x, the g of x, with x plus 7 over 4. So I'm going to be evaluating f of x plus 7 over 4. Well, in this case here, f of x is equal to 4x minus 7. That's what f of x is. So for each x in f of x, I'm going to substitute it with what g of x is. So here, this x in f of x is substituted with the g of x, which is x plus 7 over 4. And then in 4x minus 7, this x will be substituted with what g of x is. That's going to be the x plus 7 over 4. So here I'm going to simplify the right-hand side. In this case here, this 4 is like 4 over 1. The 4's divide out, so you'll have x plus 7 over 1, which is just simply x plus 7. And then bring down the minus 7. Plus 7 and the minus 7 add to 0, and you're left with just x. So the composition of f with g of x is equal to x. Now I also got to do the composition of g with f of x, which is the same thing as saying g of f of x. And when I simplify that, it must be equal to x as well for those two functions to be inverses. The inside function is f of x, and f of x is that 4x minus 7. So I'm going to bring down the g and substitute the f of x with 4x minus 7. So I'm going to be evaluating g of 4x minus 7. Well, g of x, of course, is the x plus 7 all over 4. So for every x in g of x, I'm going to substitute it with what f of x is equal to. And here, f of x is 4x minus 7. So in this x, it'll be substituted with 4x minus 7, because that's what f of x is. And in the x plus 7 over 4, that x will be substituted with 4x minus 7. Again, that's what f of x is equal to. Now, again, I can write that without the parentheses as 4x minus 7 plus 7 all divided by 4. Well, the minus 7 and the plus 7 add to 0. That's gone. You're going to be left with 4x divided by 4. And of course, these 4's divide out. You're left with just x. So you can see here, the composition of g with f of x is the same as the composition of f with g. So here, I can say that f and g are inverses. F and g are inverses, okay? So they must be the same, otherwise they're not. All right, now, let's say I want to find the inverse of a function. You're given f of x. You want to find out what f inverse is going to be. Here's the procedure for doing that. The equation for the inverse of a function called f can be found as follows. Okay, so this is the procedure for finding the inverse of a function. Number one, you want to replace your f of x with y in the equation. You'll start off with f of x equaling to something. So you're going to replace that f of x notation with y. So be y is equal to whatever. Then number two, you're going to interchange x and y. That means your x becomes a y and the y becomes x. That's what we mean by interchanging x and y. And then number three, you're going to solve the equation for y. And that means, of course, moving terms over to the opposite side to get y by itself. Then number four, replace the y that you came up with in step number three with the notation f inverse of x. So you're going to replace the y with this notation, f inverse of x, in step number four. All right, so let's apply that four-step procedure to this example. Let's say I want to find the inverse of this function, f of x equal to 3x minus 7. And I'll go ahead and write the equation, the function now, f of x is equal to 3x minus 7. And follow that procedure. The first step is to replace this f of x with y in the equation. So this f of x will be y equals 3x minus 7. And then the next step, step number two, interchange x and y. So in other words, this y becomes x, and the x becomes y. So I got x equals 3y minus 7. The next step would be to solve for y. So I need to solve this equation for y. I need to get y by itself. Let's start with the minus 7. I'm subtracting 7, so I need to add 7 on both sides. So on the left side, I got x plus 7. Those are unlike terms. We just have to rewrite it as x plus 7 equals 3y. And then to get the y by itself, I'm multiplying it by 3. I need to divide both sides by 3. So that means y is equal to x plus 7, all divided by 3. So here I got y by itself. So now the fourth and final step would be to replace the y with the notation of f inverse. So this y is going to be substituted with f inverse of x. That's what x plus 7 over 3 will be equal to. Okay. So this represents f inverse of x. Okay. All right, here's another example similar to that. Let's say we have f of x equal to 2x plus 7. And in this case, here I want to find the inverse of that function. Here we got f of x equal to 2x plus 7. All right, so the first step would be to replace f of x with the y. So this will be y is equal to 2x plus 7. And then the next step would be to interchange x and y. So that means this y becomes x, and your x becomes y. That means x is equal to 2y plus 7. And then step number 3 is to solve this equation for y. So we're going to get y by itself. Well, first of all, we're adding 7. I need to subtract 7 on both sides. So that means I have x minus 7 equals 2y. And then to get y by itself, I'm multiplying by 2. I need to divide both sides by 2. So that means y is equal to x plus 7 all over 2. And then the final step would be to substitute the y or replace the y with this notation, f inverse of x. And that's going to be equal to x plus 7 all over 2. Okay. And this is my inverse function for f of x equal to 2x plus 7. Okay. All right, let's progress to something probably more challenging, like this one. Find the inverse of f of x equal to 4x cubed minus 1. So here we got f of x equal to 4x cubed minus 1. All right, so the first step would be to replace your f of x with y. So here you're going to have y is equal to 4x cubed minus 1. And then the next step would be to interchange x and y. So that means this y will be your x. So this will be x is equal to 4 times, and the x comes y. So we got x equals to 4y cubed minus 1. X equals 4y cubed minus 1. Well, let's try to get the y by itself. That's the third step, solving for y. We're subtracting 1, so I need to add 1 on both sides. So on the left side, I got x plus 1 equals 4y cubed. Well, to get y cubed by itself, I'm multiplying by 4. I need to divide both sides by 4. So here, y cubed is equal to x plus 1 all over 4. And now, to get y by itself is being cubed. So the opposite of that would have to be to take what we call the cube root. And keep in mind that x plus 1 over 4 is all underneath the radical, because we're taking the cube root of the whole thing. Okay, now we need to continue this on the other side. This will be just the cube root of x plus 1 over 4.
A new station alert has arrived.
And then that's equal to, the cube root of y to the third would just be y to the third. No, just y. Is that we try to get rid of the cube. So the opposite of that would be the cube root. So it'd just be y. So it'd be y is equal to the cube root of the x plus 1 over 4. And then we replace the y with f inverse of x. So this would be the cube root of the x plus 1 all over 4. And all of that is underneath the radical. So this is what f inverse of x will be. Okay. All right, here's another example of that. Let's say we had this. Find the inverse of f of x equal to x cubed plus 2. F of x is equal to x cubed plus 2. All right, in this case here, we'll use that same 4-step procedure by starting with replacing f of x with the y. So this will be y is equal to x cubed plus 2. And then we interchange x and y. So this y becomes x and the x becomes y. So we have x is equal to y cubed plus 2. And then the next step would be to solve this equation for y. Well, let's get y cubed by itself. We're adding 2, so the opposite would be to subtract 2 on both sides. So here we're going to have x minus 2 is equal to y cubed. And then to get rid of the cube, the opposite of cubing something will be to take the cube root on the left side and on the right side. So that means I have a y here because the cube root of y cubed is y, and then that's equal to the cube root of x minus 2. And then finally, we replace the y with f inverse of x. So f inverse of x is going to be the cube root of x minus 2. So that's f inverse of x here. All right, now suppose you had an example like the next one here. F of x is equal to 4 divided by x and then plus 9. Okay, so let me rewrite this. So now the first step would be to replace your f of x with y. That's the first step. So it'd be y is equal to 4 over x and then plus 9. Next, you're going to interchange x and y. So that means this y becomes x and the x becomes y. So the x is equal to 4 over 9, 4 over y plus 9. Now, the next step would be to get rid of this y. We want to solve for y, but we got a y in this denominator. Let's get rid of that first by multiplying each and every term in this equation by y. So that means that this x would be multiplied by y, and the 4 over y would be multiplied by y, and the 9 would be multiplied by y. I'm multiplying each and every term in this equation by y. So on the left side, I'm going to have x times y equals 2. And in this case here, these y's divide out for 4 over y times y. I'll have a 4 here plus 9y. All right, the next step here will have to be to I'm going to do this. Move the 9y over to where the xy is by subtracting 9y on both sides. So this will be xy minus 9y is equal to 4. Because notice here, I have a common factor of y in these two terms. So that's why I moved that 9y over, so I have those common factors there on the same side. That way I can factor out this y. So this y will be on the outside. And on the inside of the parentheses, if I do xy divided by y, I'll be left with x minus 9y divided by y would just be 9. So I have y times the quantity x minus 9 equal to 4. And then to get that y by itself is being multiplied by x minus 9. So I'll divide both sides by x minus 9. So this is y is equal to 4 divided by x minus 9. Then the final step, and I had to continue this over here, I replace that y with the notation of that f inverse of x. So f inverse of x will be 4 divided by x minus 9. Okay. All right, here's another example of just this. Let's say we want to find the inverse of f of x equal to 3 divided by x, then minus 1. Okay. All right, here's what I'm going to do here. First, replace the f of x with y. That's the first step. So it'll be y is equal to 3 over x minus 1. And then next I will interchange x and y. So this y becomes the x. That's equal to 3 over y minus 1. Y becomes the x and the x becomes y. So I have x is equal to 3 over y and then minus 1. Next step, I will solve the equation for y. Now, I'm going to do this a little bit different than I did in the last example. I'm going to move the minus 1 over to where the x is. And you'll see where I'm going with this. I'm going to add 1 to both sides. So I get x plus 1 is equal to 3 over y. And then I'm going to go ahead and get rid of the y by multiplying all the way through by y, multiplying both sides by y. So here's what I'm going to do. I'm going to take that x plus 1. That's going to be multiplied by y. And over here, that 3 over y is going to be multiplied by x. I mean by y, not by x. Because I'm going to get rid of the y, so I have to multiply both sides by y. The right side of y is divide out. I'm not going to multiply the y times the x plus 1 out. I'm just going to leave it like this. Y times x plus 1 is equal to 3. And as you can see here, I can easily get y by itself. I'm multiplying by x plus 1, so I need to divide both sides by x plus 1. So here, this will be y because the x plus 1s are gone. that would be equal to 3 divided by x plus 1. And then the final step would be to replace the y with f inverse of x. That will be equal to 3 divided by x plus 1. So this is what f inverse is. F inverse of x is. Okay. Here I did the easier way by just getting the 3 over y by itself and then multiplying both sides of the equation by y. And not distribute the y over that because actually I want to get y by itself. Okay. So that's how we find the inverse of any function. Now, the last thing in this video I'm going to talk about is the horizontal line test. If you recall, the vertical line test, we use that to determine whether or not a graph represents a function. When we do the horizontal line test, we're going to determine whether or not each graph has an inverse function. All right, so now a function f has an inverse that is a function f inverse if there is no horizontal line that intersects the graph of the function f at more than one point. So if that horizontal line crosses the graph at more than one point, you do not have an inverse function. Okay? It can only cross that line, the horizontal line can only cross that line at only one point. So if you look at these these examples here, graph A and graph D have an inverse function because I can draw a horizontal line. It's only going to cross the graph at one place, at only one place. And I'll go ahead and show that here. So here, a horizontal line is crossing the graph at only one place. And on graph D over here, that horizontal line crosses the graph at only one place. So those have inverse functions. The two in the middle, graph B and C, do not, because that horizontal line crosses the graph at two places. The same here. This graph, well, the horizontal line is crossing the graph at 3 different places. So these two do not have an inverse function. All right, so let's take a look at this example here, example 9. Refer to the graphs to determine which ones represent functions that have inverse functions. Take a look at part A. This is what the graph looks like. I want to know if that has an inverse function. Well, if I draw a horizontal line through that graph, that horizontal line crosses the graph at 2 different places here, as you can see. So this graph, graph A, has no inverse function. All right, that's all there is to it. Let's look at graph B. I want to know if that has an inverse function. Well, in this case, I can draw the horizontal line anywhere. You can see that horizontal line is only crossing the graph at one place and only one place. So that means graph B has an inverse function. And now graph C looks like this. If I draw a horizontal line through that graph, it's only crossing the graph at only one place here. So that means this graph also has an inverse function. Okay. So that's how we use the horizontal line test to determine whether a function does have an inverse, or the graph of a function has an inverse function. And those that do have an inverse function, are what we call one-to-one functions, okay? A one-to-one function is a function in which no two different ordered pairs have the same second component or the second y coordinate, okay? So in this case, if I have the relation -5, 9, 2, 0, and 8, -1, this is a one-to-one function because if you look at your y coordinates here, they do not repeat. On the other hand, -1, 8, 5, 7, and -5, 8, that's not a one-to-one function because notice you got the y coordinate repeating for 8 because 8 is with -1 and 8 is with -5. So here your second component or the y coordinates repeat. That's not a one-to-one function, okay? And only one-to-one functions, as I mentioned, have inverse functions. And any function that passes the horizontal line test is a one-to-one function, okay? And any one-to-one function has a graph that passes the horizontal line test, okay? Okay, so if a function has the horizontal line test, that means it's a one-to-one. But if it's a one-to-one function, then that means it's going to pass the horizontal line test. Okay. All right, so that's all I have to mention in this video. So that will conclude this video on section 2.7, inverse functions. Feel free to email me if you have any questions about the examples that were discussed in this video, or if you have questions about the homework in my math lab for this section.